this video, we're going to look at some projectile calculations with the kinematic equations. So there are 4 of these kinematic equations, and all the variables are variables that you should be familiar with already. So of course, VF would be a final velocity, VI an initial velocity, A is the acceleration, and when we're talking about the vertical component, that would of course be gravity. T is time, and D is the distance or displacement. So that would be how far something travels or how high something is. So let's go ahead and look at the first one. So there is a stone thrown horizontally, meaning it's somewhere up on a cliff and it's just launched straight out. So it would have that half parabola curve from the top of a cliff with a velocity of 15 meters per second. It takes 3 seconds for the rock to land. So we are being asked, how high is the cliff? So we know some givens. So we know that our horizontal velocity is the 15 meters per second. So we would label that as our VIX because it's our initial velocity in the X direction. X goes with horizontal. And that is 15 meters per second. We know that for things launched horizontally, that their initial vertical velocity, their VIY, is 0 meters per second. And it does tell us the time is 3 seconds. And as always, our gravity or our acceleration in the y direction would be negative 9.8 meters per second squared. And again, we're being solved for how high the cliff is, so variable D. So to figure out which equation that we should use, one method that you could do is to go through and underline or circle all of your knowns, everything that you're given, because that will help you determine which equation you can actually use. So just remember for this, we're looking for the distance that an object falls. We're looking at y component variables. So that means we are not going to be using the initial velocity in the x direction at 15 because that's in the x direction. We're only worried about the y direction equations. You cannot mix and match x and y components. All right, so we were given the initial velocity of 0. We were given the time, the 3 seconds. We know that it is falling downward, so gravity is going to be acting on it. So we know the acceleration involved would be gravity. And we are looking for the distance or the displacement of the object. So knowing this, we cannot use this equation because of course it doesn't even have variable D. We can't use this one because we don't have the final velocity. So we could use, well, we have to use this one because again, we don't have the final velocity. So knowing that we have to use this equation, we can write down the original. So this is distance equals the initial velocity times time plus 1/2 times the acceleration, and the acceleration in the y direction, of course, is gravity, times the time squared, and only the time gets squared. So next we can plug in and substitute all of our variables. So we know that the initial velocity in the y direction is 0. We know that the time is 3 seconds, plus the 1/2 times gravity, which is the negative 9.8, and your time is the only thing that gets squared here, so 3 squared. Now we can simplify. So we have D equals 0 plus a negative 44.1. So when we simplify that, of course, our answer would be a negative 44.1 meters. So it's negative because, of course, the object is falling down the 44.1 meters. But when you answer the question, how high is the cliff, of course, you wouldn't say it's negative 44.1 meters. You would just say it's 44.1 meters high. All right, next one. So continuing with this stone. So same scenario. Its horizontal velocity is the 15. The time is the 3 seconds. And for this part, part B, we're looking for how far from the base. So another distance. So if the base is here and the stone was launched this direction, we're looking for how far outward did it actually go. So we're looking for the distance in the x direction. So all of our variables that we're going to be using have to relate to the horizontal or the x component. All right, it's the same givens as before. So our initial velocity in the x direction, it told us that it was launched at 15 meters per second. We know that the initial velocity in the y direction is 0, although we cannot use that because it's a y direction. Can't mix and match. The time is still 3 seconds. We know that the gravity in the y direction, right, because gravity only acts vertically, is negative 9.8 meters per second squared. However, we cannot use this type of acceleration because that's gravity, and we're looking at the x direction. So, we've talked about the concept that if objects are thrown, launched, moving through the air with some sort of horizontal velocity, that there are no forces acting in the horizontal direction. Gravity does not act left or right, so our horizontal acceleration in the x direction would be 0 because there's no unbalanced forces to slow it down. So there is no acceleration. That's why as it moves horizontally, the horizontal velocity remains 15 meters per second. So because it's a constant velocity, there is no acceleration. Our unknown is distance, and again, this is the distance in the x direction because we're trying to figure out how far from the base it actually fell. So knowing that we need to solve for distance, let's figure out which equation we need to use. So we know we can't use this first one, it doesn't even have distance. For this one, we were not given the final velocities. So again, we're left using this equation. And just to verify, yes, we were given the initial velocity. Yes, we were given time. Yes, we know the acceleration is 0, and we were given time again. So once we write down our original equation, we can now plug everything in. So we know that the initial velocity is 15, because again, we're using the initial velocity in the x direction, times the time of 3 seconds, plus 1/2 times the acceleration. Remember, we're talking about an acceleration in the x direction. And for the x direction horizontally, there is no acceleration. It's constant. So it is 0 times the time squared. So the 3 squared again. All right, once we simplify, of course, all of this turns to 0. So 15 times 3 is 45 minus 0. So the distance that it travels, how far from the base, is 45 meters. And again, this is our distance in the x direction. All right, part C, last part with this stone being launched off of a cliff. So same givens, 15 meters per second horizontally. The time is 3 seconds. And of course, we already have several givens that we knew from the previous parts A and parts B. So part C, it's asking how fast is it going when it hits to the ground. So we're going to be looking at a final velocity, and we're going to be considering that we're looking for the y direction. So here are all the givens that we were always given. So our initial velocity in the x direction, it says, was launched at 15 meters per second. We know that the initial velocity in the y direction is 0. The time, it said in the word problem, was 3 seconds. We know that the acceleration in the y direction is gravity, because gravity only acts in the y direction. We know that the distance that it falls in the y direction is 44.1 meters, because we previously solved for this. And we know the distance that it fell away from the base, so the distance in the x direction, is 45 meters. And again, our unknown is the final velocity VF, and we are looking for it in the y direction. So, knowing that we are looking for the final velocity, let's determine which equation that we could use. So we can't use this one because it does not have a final velocity. We know the distance. We know the acceleration, which is gravity, because we're talking about the y direction here. We know the time. And we know that the initial velocity is 0. So really we have tons of options here, and it doesn't matter which equation you pick, it will give you the same answer. For this one, we're going to use this equation. So we have the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration, or gravity, because again, y direction, times the distance. So we can go ahead and plug in. Our initial velocity in the y direction was 0. 0 squared is 0. Plus 2 times gravity, which we plugged in here, and times our displacement that the object fell. So that would be the 44.1 meters. Once we simplify, so 2 times 9.8 times 44.1 is going to give you 864.2 meters. But again, this is velocity squared that we just found, and we don't want it to be squared. We want just regular final velocity. So in order to get final velocity, we are going to have to take the square root of this number. When we take the square root of 864.2, our answer is 29.4 meters per second. So, the discrepancy here is that our distance we could have plugged in to be positive. But no worries, between positive and negative, it's really not that big a deal because at the end of the day, it doesn't change the magnitude of your velocity. So you would have gotten a negative 29.4, which would have been correct. However, it's also displacement. So you could have plugged in the negative 44.1, still got 29.4 meters per second. Either way, consider that we were finding the final velocity of an object that was falling downward. We know that downward is negative, so that's why it has to be that negative 29.4 meters per second. So if you're worried about positive and negatives, don't stress about those. You can always consider that if an object is falling down, it will be a negative velocity. If an object's being thrown upwards, upward would be a positive velocity. So keep that in mind as you're solving these problems independently. All right, let's do one more. So we have a football that's thrown directly horizontal with an initial velocity of 24 meters per second. The final velocity in the vertical direction is 28 meters per second. How long did it fall? All right, so we're given quite a few things in this problem. So we know that the initial velocity in the x direction, horizontally, was 24 meters per second. So here we have Vix is 24 meters per second. It tells us that the final direction in the vertical direction, or y direction, is 28. So our Vf in the y direction is negative 28 meters per second. And yes, it is negative because remember it is falling downward. Down is negative. Our initial velocity in the y direction we know is 0 meters per second because it was being launched horizontally with this path. And we know that at that first position, there is no initial vertical velocity. All right, so we're looking for time. How long did it fall? So looking at all of our equations, we don't know a distance. So we cannot use anything with a distance. That leaves us with one equation that we can use. Vf is equal to Vi plus acceleration times time. And remember, our acceleration is gravity. Because we're looking for the time that it fell, we're considering the vertical direction, or the y component. So technically, none of their given would have been acceleration or gravity, the negative 9.8 meters per second squared. All right, so once we plug in, our final velocity we said was the negative 28 meters per second, equals our initial velocity, we started out at 0, plus acceleration, or gravity, negative 9.8, times time. So now we can solve for time. So once we simplify, we would have a step in between if you need to see this. Negative 28 meters per second equals negative 9.8 times time. So we have to divide by 9.8 on both sides. That's how we got to this step here. So negative 28 divided by negative 9.8 would be 2.9 seconds. So the time that it takes to fall is 2.9 seconds, so a very quick time. All right, that is all the calculations that we're going to do for this video. Thanks for watching.